Thanks everybody for being here. I'm Sébastien Deleuze. I'm working for Pivotal as a Spring Framework developer. And today I'm going to talk about Spring, but used in a different way you are used to, with Kotlin and a more functional approach. Safe harbor statement, because I'm going to talk about a lot of forward-looking stuff, experimental stuff, incubating stuff. And let's start to talk about Kotlin from a Spring point of view. I push for Kotlin, and I believe in Kotlin because it allows Java developers to leverage their existing knowledge to write shorter, safer, and more explicit codes. When I'm talking about this knowledge, I'm referring to the Java knowledge and also to the Spring knowledge. It allows to write a code with a better signal-to-noise ratio. At the left, you have the Kotlin code. At the right, you have the Java code. It's basically the same structure, but you can see that with data classes, you are able to define the constructor parameters and the properties at the same time, getter and setter with a single line. It's this kind of design push for immutable classes with the val keyword. You can see that we deal with null safety at the type system. So by default, types are not nullable. That means if you put null in this property, 0 will be raised at compile time compared to Java where it's at runtime. And if you want to make a type nullable, you add a small question mark at the end, like for the description string parameter. And data classes, the data keyword allow you to generate two strings and various other things. So really, it's really about having a better signal-to-noise ratio. It's useful when you write your code, but especially when you have to debug to maintain a large code base, it's much better to have less code to maintain and to express things more clearly. Usually when people have not tried Kotlin, they say, okay, it looks like a little bit groovy. It's a little bit different. It's really even more statically typed than Java. So first, Groovy can do static typing, but that's optional. And a whole part of the Groovy ecosystem is mainly based on Groovy in a dynamic way. While in Kotlin, we have the same culture of Java in terms of static typing. And I would say that Kotlin is even more statically typed than Java because of the null safety thing. And it's not a detail to me. That's very important, because in Java, sometimes we think about commenting, OK, this parameter could be null or not null, but usually we forget. And it's basically something that is a source of a lot of issues. Kotlin, we are going to talk about Kotlin today with Kotlin DSLs and functional programming, but it's also a good fit with the annotation programming model. So here you have an example of a controller, a regular REST controller, where we use Kotlin instead of Java, and you can see that the code is shorter, but basically this is the same structure, and Kotlin is a good fit for that kind of programming. In terms of evolution, the Kotlin rise continues, mainly driven by the Android developers. Last year, Google announced that, or maybe 2 years ago, but not now, Kotlin is the official language to develop Android application, and that means that a huge number of mobile developers are training and are becoming Kotlin developers. And even if this rise is mainly driven by Android developers, I mean, some developers do both mobile and server-side development. And we can imagine that, for example, when you start to develop a project, an Android project in Kotlin, you want to share this knowledge about the language, and you want to also develop the server in Kotlin. So this move will have an impact on the server side. Obviously, the move will be much slower on server side, because server side moves slower, and also because we have a huge number of Java developers. But I think we are going to see the number of Kotlin developers growing. We can see that it has overtaken Scala. At least some people could question the metrics here. This is the number of questions on Stack Overflow, but what I want to show is mainly the tendency. The tendency is a big rise, a quick rise, and what is interesting in this graph is that Kotlin is becoming not just an alternative JVM language, but is becoming slowly, quickly, a major JVM language. And let's put that in perspective with the figures of Java. So we can see that compared to Java, Java is much, much more used. It's far away, but the tendency is clear. Usually with the other JVM language, we don't really see them on this scale. And here we see that we are going to move in a world where there is two main JVM languages, and that's something that's never happened. So it's an interesting time. So before I talk about all the forward-looking stuff, if you want to use Kotlin today in production, it's totally possible. We have official support for Kotlin in Spring Framework 5 and 5.1 and Spring Boot 2.0 and upcoming 2.1. I would advise you, if you have not tried Kotlin before, to just go to try.kotlinlang.org and do the small exercise. You can also do that in your IDE. In terms of books, I advise you to read Kotlin in Action. It was, in fact, written for Kotlin 1.0, but it's totally relevant now. And if you want not to see screens too much, just write the paper version. I think that's a good buy. And I have written last year a tutorial which contained basically everything you need to know. Everything is in that, so go to spring.io, go to the guides, search Kotlin, and you will see there is a complete tutorial that is about building a Spring Boot 2 application with Spring MVC and the latest Spring Framework 5 features like the web client, for example, instead of the REST templates. And every tips, every information is in this tutorial. So that's, if you want to use Kotlin today, you have everything to do that. Now, let's talk about the more forward-looking stuff. Spring Framework 5 introduced first-class Lambda support, functional, bean registration and web routing, reactive programming model, and Kotlin support and DSLs. So if you have not seen that in previous talks, the router DSL is like that. So it's about leveraging, providing a Kotlin DSL that leverages the Java building blocks that Arjen Poetsma provided in the new functional web framework based on Webflux, which is part of Spring Framework 5. And we provide that with a nicer Kotlin DSL that allow you to basically define routes using request predicates. Accept application JSON is a request predicate. The string is the equivalent of path with the parameter, which is the path itself. You can use nested routing. You can combine these request predicates using and or not. So it's super powerful. You can write your own request predicates, and you can do dynamic stuff that you can do with the annotation programming model. So imagine you are developing an e-commerce or CMS thing that are usually in PHP, because in this kind of application you need a lot of dynamic thing. You are able to do things at startup or each time you receive a request. And there's a big, in addition to it's a different taste of expressing your routes, it's also something that deals with dynamic routes, and that's powerful. And you see that's a functional DSL with code, but you can plug it in Spring Boot 2. So in Spring Boot 2, if you declare a bean that's under the return value of the router DSL, it will use it to route your request. The other DSL we provide, the other Kotlin DSL that we provide in Spring Framework 5 is the bean DSL. So the bean DSL is a way to define your beans programmatically. It is the most efficient way to register beans because this is a super thin layer on top of the low-level Spring bean registration API. So it allows basically internally just calling generic application context.register bean. And as of Spring Framework 5, we can create such bean by just providing the class. So in the DSL, when you do that, it will also handle auto-wiring of constructor parameters. So you don't have to provide all the parameters. It will be done automatically by constructor parameter auto-wiring, so quite powerful. And you can also provide yourself the instance of the bean by using a supplier. So if you have a look to the custom bean example, here we are providing with a Lambda an instance that we create ourselves, and we can provide directly the constructor parameters. We can call any custom setter or call any setter. And you just return the instance. And in Java, you would have to specify custom bin.class n to provide the instance. In Kotlin, thanks to reified type parameters, which allow to avoid type erasure, basically. That's a small tweak, but a useful one. We don't have to repeat the type, so the syntax is quite nice, I think. And again, it's programmatic, so you can use any kind of custom condition with if, for loops. Here, I provide a built-in one, which is profile. So everything that is in the profile lambda will be run only if the custom profile is enabled. So that allow you, like you did in XML and in Java config, to define some custom profile and have something modular like that. So that's where we were last year. And I had a lot of open questions in my head, because that's usually like I work. And so I share with you these open questions. The first one is, what if we apply this Kotlin DSL principle to Spring Boot configuration? That may look like a silly question, but we have seen with this example that we are in the middle of two worlds. I mean, we see that we have annotations, but we have also functional DSL, and it could be perfectly fine for some people, but to limit the cognitive load, maybe I would like to try to use the same principle everywhere instead of having some things based on annotation and something based on lambdas. So that's a question I ask myself. The other one is, what if I prefer explicit configuration? I mean, Spring Boot auto configuration is amazing. It's really powerful. There has been a lot of talks to explain how it works, and that's a very nice building block. But Spring is also a matter of choice, and it's also a matter of taste. I mean, personally, I prefer explicit configuration. I prefer to write a little bit more configuration, but to be in charge of enabling everything. Yeah, that's a matter of taste, and maybe in other technologies, in other like Node.js, Ruby, or things like that, maybe that's how people are used to work. Another question I was asking to myself is, can Spring applications be more efficient by leveraging functional configuration? If you have seen Dave Sayer talk previously, and I have done a lot of work on that too, I quickly figured out that leveraging functional bin registration is not only for the user-facing part, it's allowed to go faster and to consume less memory. So if you use functional bin registration for boot internals and for your application, maybe this is a way to go faster. We will see that after. And a Kotlin-related question was, could coroutines make Spring Reactive stack easier to use? I mean, Webflux is super powerful. It's very scalable. It allows to do advanced stream processing. But learning a Reactive API is not a free lunch. We all know that. So maybe coroutines could be a way if you just want to build a small CRUD application, but you want at the same time to leverage a nice reactive non-blocking runtime to scale better. Maybe you just need coroutines, and you don't need all the power of Reactive API. So I have think about that, and I have worked on something which I introduced today, which is Kofu configuration. Kofu configuration for Spring Boot is an explicit configuration via Kotlin DSL. It's based on Spring Boot infrastructure used in a functional way. It's experimental and incubating. You don't use that in production today, okay? That's the first time I present that into a conference, so this is really the first stage. There is no feature enabled based on classpath detection. Everything is explicit. I will show you that in a demo shortly after. It's both declarative and programmatic. Declarative because it looks like barely. I had some people saying, okay, but isn't it like YAML or XML? Yes, but at the same time, it's code. I can use if, for. I think it has the advantages of both approach. Faster startup and lower memory consumption compared to the Java config approach. We will see the figures. Minimal reflection and annotation usage, and it uses pure lambdas, no CGLib proxy. So Kofu configuration is currently developed in SpringFu, and SpringFu is a project, an incubator intended to ultimately contribute features related to Kotlin and functional configuration to Spring Framework, boot, and data. The goal here, the strategy here, is not to create another Spring project because there is so many. And Spring Boot is really the single entry point, and the idea is really to leverage that. The purpose of Spring Foo is to provide a collection of features that are related together. But the ultimate goal is to incubate features in this incubator, and later to contribute this feature back into the existing project that you already use. And obviously, there is some new features, so we need to make sure that these new features integrate well into this existing project, but that's really the goal and the strategy. So we are going to switch to a demo. So I'm going to create a new project. I will make the fonts bigger after that. Like I said, projects with Kotlin configuration are based on Spring Boot. So what I do, I create a Spring Boot application like I do using start.spring.io. I can go to the website, or here for easier demo, I will directly use the integration in IntelliJ IDE. So, OK. I choose Kotlin, and I'm going to name it Demo Kofu. Here, I'm going to use Spring Boot 2.1 M4, OK? And I'm going to use the Reactive web stack, Mustache, and Reactive MongoDB, and embedded MongoDB. That's it. OK, let's create the project. OK, so here we have a regular Spring Boot project created from start.spring.io, and now I'm going to show you how to leverage the Kotlin configuration. So the first step will be to update the Kotlin version, because I live on the bleeding edge, and I need the Kotlin 1.3 provide final coroutine support, and since I will use coroutine in this demo, I need to update, but you can totally use it with Kotlin 1.2. There is no issue in that. In order to be able to download this RC version, I need to add a repository here. So I'm adding the repository and the plugin repository. Yeah, I'm not a live coding god, so I use heavily live templates. Yeah, I'm not Josh Long, sorry. Something interesting, we enable the Spring Kotlin plugin in order to automatically open classes, because in Kotlin, by default, classes and methods are final, and you have to use the open keyword to make them open. But here, we don't use Java config, we don't use CGLib proxies, we don't use transactions, so we don't need this plugin, so I will just delete it. For Spring Functional application, we don't need that. I will also remove the test scope, because I want to use embedded MongoDB also for the main one. Obviously, in production, you won't do that, but that's just to show you. And I'm going to add the dependencies, the Kofu dependencies. So I'm going to add 3 dependencies. You will see that these are dependencies with the org.springframework.foo group ID. And for the artifact ID, I have chosen to indicate the project that they extend. So basically, Kofu is built on top of Spring Boot, so there is the spring-boot-kofu artifact. Notice that I have released the 0.0.1 version. I'm very careful, but it's usable, but that's very first version yesterday. And also, I provide coroutine support for Spring Web Flux and Spring Data MongoDB. Obviously, this coroutine support goal is to be contributed back to Spring Framework and Spring Data later. Currently, it will incubate on Spring Foo side. OK, so OK, migrate. OK, so now we are going to turn this regular Spring Boot annotation-based application into a functional one. So the first thing I will do is to declare that. Okay, so I declare an application with the application DSL. In terms of running it, it's super simple. I will just run and provide the args. So you can see as a functional equivalent of Spring Boot application in a functional world with a Kotlin DSL. And here, things change a little bit because you will see this DSL is code. So I can leverage full autocomplete to be able to write my code. I have also documentation. So if I go here, you have documentation. I need to find a way to provide the code samples, but it's just a small thing I will fix later. But if you go to the HTML version, you will see that I provide code samples everywhere. These code samples are, in fact, compiled from the project. So you are sure that the code samples that I provide really compile and are in sync with the project. And everything is discoverable. So you will see here, I'm in application. I can see that I have a beans block, import beans, logging, profile, properties, run, stop, everything. This could change. The API will evolve. But the good thing is that everything is discoverable and a little bit more centralized. We will see that we need to find the right trade-off between too centralized and everywhere. But yeah, this is another way to configure your application. So for example, if I want to configure the logging, I will do that. So with log level debug, I configure the root log level. You will see that here. I'm using Spring Boot log level class, so Kofu configuration don't try to reinvent the wheel. It leverages Spring Boot internals and provide a more functional, a more DSL way to configure it. But inside, I'm leveraging all the logging system Spring Boot infrastructure to do that. I can specify that the level of log for this class should be info, and I can also specify for a specific package. That's it. I can declare a server. So I declare a server like that. I will declare a router. And here, this is the router DSL I've shown you before. Okay. So I will just write something super simple for a start. Okay. Sync body. Hello. Spring 1. And that's it. So to run it like a regular Spring Boot application, I just run it like that. OK, and if I go to localhost, OK, hello Spring 1. No, so that's a very simple one, but that's just for a start. That's a basic application. Now, if we try to provide a more realistic example, let's build something that has a MongoDB database, for example. So we are going to add a user. So that's a Spring Data document, okay? We are going to provide a repository. So in this case, the repository will use the coroutines version of the Mongo template that I provide in Spring Foo. But you can also use the reactive ones. That's perfectly fine. To be able to use it, I will declare MongoDB like that. Again, this API will evolve. That just to show you the principle. I will polish the API. OK, and that's OK. Now I'm going to have my handlers. So like that. So here again, that's a draft version of the coroutine support. You can totally use the reactive support, which sample properties. I will also add that. So here is the equivalent of the configuration properties. So I just write regular classes like I do with configuration properties, but instead of annotating it, I will just write that. So this is the functional equivalent of add configuration properties, okay? Just another way to define it. I will obviously define the matching properties here. What can I do? I can maybe add, this is to use a view, but I can also provide that as an API, JSON API, so I will add list API, okay, body, here, repository.lists, okay. I import the Kotlin extension. I'm going to add a more complete example of the server. So this one is going to be interesting, and we have a few things to see here. Let me just import the various things. Okay, let me also write the API one in order to not forget. So API and list API. So here you see I'm using method references. I need to declare the beans. So beans like that. Here I'm leveraging the beans DSL, okay? So I'm going to declare user handler. These beans will be automatically auto-wired by their constructor parameters, user repository. And since people have expressed concern, okay, in my application I have a huge number of beans, I need to declare everything manually, I don't want to do that. I have implemented a bean scanning, which is quite fast, despite what say people, it's super fast. So with this version, you specify basically your package, it will automatically, so the current behavior is that it will automatically try to auto-wire every class it finds in this package. Obviously, we will maybe provide a filtering mechanism or thing like that, but that's just to show you that that's compatible with a bean scanning approach, and each bean found will be automatically auto-wired by its constructor parameter. That's perfectly fine, that's up to you. In this example, I will declare everything like that. You see that, again, that's discoverable. I can have a look to the documentation easily in my IDE. When I will fix that, I will show the code example as well. You see that, for example, in Jackson, I can configure a lot of advanced things here. Here, I'm just indenting the output. The codec management is interesting. It's a little bit different to what you are used to in Spring Boot and in Spring Framework. As I said before, Kotlin configuration is explicit. That means that if you don't declare any codecs, obviously I configure once by default because let's be pragmatic. So I configure only the resource one and the string one. But if you declare a codec, which is the equivalent of the HTTP converter in Webflux world, you will only get that. So we usually have people complaining, there is some conflict between the string and the Jackson converter, and the one pickup is not the right expected. So if you just want the Jackson one, you just declare the Jackson one, and so you are in control about what is here. We support also protobuf, which is a new feature I implemented in Spring Framework 5.1. And what is also interesting is that external libraries could provide extensions for that. So an external library can provide an extensions, Kotlin extensions that will make it possible to add a new codec without having everything centralized. So the Kotlin extensions here are a way to make this model extensible, even if when you write that, you have the feeling that everything is provided by Spring. What I missed, okay, I need to create also the templates. So let's create templates directory and an index dot mustache template. Okay. Oh, I forget to initialize the data. You see here, I have an init data method, and I would like to initialize my data at the startup. So what I can do is to declare a listener, okay, of type application ready event. So it just, what I do in Kofu is just leveraging all the Spring building blocks, but providing access to that in an explicit way with a nice DSL, but we are just leveraging the regular Spring building blocks. And here I'm going to write run blocking because that's the coroutine equivalent of dot block. And I will get, so that's funny because I can get a reference of user repository. Okay? That's the equivalent of context.getBin, init data, and that's all. So I'm going to run this application. I hope I have forgotten nothing. So let's run it. Okay. So here we see that we have our mustache view that is rendered. If I go to /API, we have our JSON. That's okay. What I can demo you also is maybe integration tests. So the testing part is really an area where there is a lot of work to do. But I have worked for now on integration tests. So you can currently it's like that, but really, we need to discuss that. Maybe we need to support regular Spring Boot annotation for test. I'm not sure, really. I'm totally open. What I can say is that since I have something that is really runnable easily, here I'm just doing app run with a test profile. We change the port to be able to run my test when the application runs. I use web test clients, and I check the content of my of the REST web services. So yeah, this area will evolve, I guess. So let's continue the presentation and stop that. Okay. Okay, for the demo. So, okay, but what about Java? I mean, this is interesting stuff. We leverage all the Kotlin goodness to provide this kind of DSL. But Spring Boot is not only about Kotlin. It's a huge part of Spring Boot developer are Java, and I believe that we can't avoid that. So I have a good news. I have created a Jafu. So Kofu is for Kotlin and functional. Jafu is for Java and functional. Honestly, before working on that, I was not sure it would be usable in a real world. I mean, it's doable, but the API is quite good, in fact. You have to put explicit Lambda parameters. If you provide a supplier of bin, you will have to provide 2 times the type. But the API is quite good. In this version, I'm able to leverage the new Java router DSL that Arjen Poetsma provided in Spring Framework 5.1. So we have something that is super close to the Kotlin DSL. To me, the biggest issue is the lack of Kotlin extensions, because with Kotlin extensions, I'm able to basically allow external libraries to contribute DSL elements everywhere in Kofu, where with Jafu, I think we will have to use some kind of static methods, and that won't be as smooth as I would like. So to me, this is the real issue to solve, and I guess we will find a way, but it's doable. And the thing is that in terms of architecture, I worked on something that really separates things. So Jafu and Kofu are based on Spring Boot. We leverage Spring Boot auto-configure with the Spring Boot full-configure, a lot of new artifacts, module that basically translates Spring Boot auto-configure, which provide auto-configuration using @configuration and Java config. And it turned that into application context initializers that are a low-level Spring building blocks, and that's the root of the registering bin in functional bin registration. This application context initializer constructor take, for example, server properties or this kind of thing from Spring Boot. And basically, with that infrastructure, I am able to specify the right configuration using server properties, etc., from Spring Boot, and create that in a functional way. Currently, I have done this work manually, but Dave Sayer, Andy Clement, and the boot team are beginning to experiment about maybe generating that automatically. So there is some really, really early work on that, and not any promise, but on the principle, we have everything in terms of information in Spring Boot auto-configure to generate automatically a functional variant during Spring Boot build. So it won't impact your build. So the idea, and that's just in theory, we should be able to remove the Spring Boot full configure, and it will be better in terms of maintainability to be able to directly leverage Spring Boot capabilities that would allow to register beans in functional way. Currently, it's not available, so we have this layer of adaptation, but yeah, it's proved that it's possible. Because basically, we are just registering beans using the methods that are annotated with admin and using object provider, things like that, so it's really doable. And on top of that, we have Spring Boot Jafu, Spring Boot Kofu. Currently, in the 0.0.1, only Spring Boot Kofu is usable. Jafu is just a POC for the moment, but I plan for the next version to make both, to reach functional parity between both and evolve both together. Other features incubated because Spring Foo is wider than Kofu and Jafu. Other things I incubate in that is the coroutine support. So coroutine is expected to be final in Kotlin 1.3, which will be announced, I guess, next week at Kotlin Conf. In fact, they are not ready. So they are going to remove the experimental from the package. But there is a big missing point, and I'm going to talk about that. So coroutines, big selling point is that for single values, single asynchronous values, you don't have to use a wrapper to deal with that. So instead of writing a method that returns a mono of t or a completable future of t, you will just write a suspendable function that returns t and that makes your code indeed more imperative-like. And it's interesting for, I would say, basic use cases. So if you are just writing a CRUD application and you don't need all the streaming processing thing, that's fine. That allows you to leverage a non-blocking reactive runtime with almost no cost in terms of cognitive load when you read and program your code. But as soon as you deal with just simple things like collection or call streams, so call streams are basically, I want to be able to process the element of a collection as soon as they arrive and not with a regular list at the end. This is obviously supported by our reactive APIs, and we use Flux for that. But on coroutines, it's not supported yet. There is a very long discussion with Roman and Elizarov about that, and they said, okay, we need to go final for Kotlin 1.3, so we will bring this call stream support. It will be on the library side of the coroutines, and it will be post 1.3. I will push for getting that shortly because we really need that if we want to support coroutine in Spring. Hotstream are supported via receive channel, but I think it's much less compelling use case because in both cases you use a wrapper. I think Reactive API are more powerful. The back pressure management is much more powerful. So when you are going to use very powerful stuff like R2DBC or Reactive Socket that we presented today, here you are really beginning to see differences between Reactive API and coroutines. So for that use case, I think even in Kotlin, it will be better to stay with Reactive API. But if you are just writing a small CRUD application, just use coroutine, that's better. That's simpler. There is another use case for coroutine. It's to be able to write new operators and to add them into Flux or Mono. With Kotlin extensions, you can add a new method to Flux and Mono, and coroutines make it super easy to write custom operators, while without coroutines, you need to be Stéphane Maldini, Violetta, or Simon to be able to do that. So that's interesting. Another interesting feature I have worked on this last month was GraalVM native images. So GraalVM is a kind of new experimental VM for Oracle. In fact, they work on that for several years. And it allows to, it has a sub-project called Substrate VM, and Substrate VM allow to compile Java and Kotlin and any JVM-based program into a statically linked native executable like Go. And that sounds strange, but in fact, that works. It has very fast startup, low memory consumption. Theoretically, that's not the best option to run server-side application because there is no runtime optimization. So we can think, OK, there is not hotspot that will optimize things when we run the server. But in practice, it seems to perform pretty well. So let's do some benchmark. But it's not it could be used for server-side as well. We provide initial support in Spring Framework 5.1, but the big part of the work needs to be done on GraalVM side because they support basic Java application, but not very, very advanced ones. And we have created, mostly devs here, I created, I guess, maybe 20 issues on their side, and they have fixed 6, so they need some work. What I can say is that why regular Spring Boot application with annotation will not run with GraalVM until maybe 1 year, I would say. I don't know, but there is still significant remaining work to do. With functional applications, it works today, not for every use case, and obviously there is also things to fix on GraalVM side, but it should work. We are going to see that now with the demo. So I'm going to go to, with Kofu, I publish bootstraps. Bootstraps are pre-configured project samples, some like archetypes that allow you to start. And since Graal require additional configuration, I could go from start.spring.io, but that will require too much configuration work, so I do the lazy thing. Okay, so I'm going to desktop. I'm going to go for Graal. And this is a regular Spring Boot plus Kofu configuration application. So you can see, okay, super simple program. I can show you that I have a build.sh. So, I'm tired, sorry. Okay, so JT and Netty are currently supported. We just care about Netty today. So what we are going to do to build this this Spring Boot application with Kofu configuration with GraalVM native image, that's very long to say, it's to just compile our regular program using Gradle, okay? We are going to do that with GraalVM 1.0 RC6, and then we are going to compile it into a native statically linked executable using native image. Native image is something provided by a Substrate VM. So first, I switch with SDK man to the right version of. So this is a GraalVM 1.0 RC6, and then I will, if the demo gods are with me, compile it. So the first thing is to. It will compile the program with this alternative version of the JVM with Gradle, so nothing super fancy here. And then I'm extracting the fetchjar to get a regular class path, and the program is run by the compiler. So in fact, the Substrate VM is currently running my program, analyzing all the bytecode, and compiling it to a statically linked executable. So it takes some time. You see, it's not designed for a development experience. When you develop that, you will keep using a regular JVM. It's more about creating an artifact for a deployment target for your servers. So it takes some time, like usually with static compilation. And at some point, we should have something that is runnable. So this part is slow. Yeah?
With the functional configuration, is there a way to integrate that with Swagger?
Could you speak?
With the functional configuration, is there a way to integrate your routes with Swagger?
Not yet, but that's a topic I would like to work on after. So there is an issue about that in Spring Foo. You can have a look and comment. There is an issue about that. So it should be OK. So now you can see that I have a com.example.application KT executable. It is 56 megabytes, but it contains everything, the platform and the application. And then I think, I hope it is not running on the background. it's starting in 6 milliseconds. And there is no trick. I mean, it's just starting in 6 milliseconds. If I go here, it works. And so it's pretty amazing. I mean, it starts fast, but also it consumes very few memory. So if I have a look here, and I try to find com.example, okay, resident memory. It consumes how much? Oh, it's a bit more. So 78 megabytes of memory, but I think we could optimize that quite a lot. So in terms of deployment, you don't need any GVM runtime. You just have a static executable. Currently, it does not support ARM, but I think it will support. So to deploy application on embedded device that just dream target, nobody needs a full-fledged GVM when you deploy to very small devices. And yeah, I think that's something promising. That's really early stage. Don't expect to use that today in production, but I think that's pretty interesting to be able to start a full-fledged Spring Reactive application in 6 milliseconds. So speaking about startup time, so obviously the Graal native image version start too fast to be able to see it here, sorry. But if we compare regular startup time, we can see that there has been a lot of optimization into Spring Boot 2.1. So if you just run your regular annotation-based application using Spring Boot 2.1 instead of Spring Boot 2.0, you will just go faster. You have nothing to do. You can refer to Dave Sayer, very good talk about that to understand all the optimization that has been made. But another thing is that I said before that functional bin registration is the most efficient way to register bins. And it's not only about Java config versus functional bin configuration. It's also about here I have an explicit configuration, so less condition to evaluate. I don't have to parse all the annotation metadata to wire things. So obviously this is various things put together that allow to start a Spring application in less than half a second. But it's interesting to see that with this kind of infrastructure, a nice thing is that it consumes less memory, it starts faster, and I think it's promising for the future. So conclusion, if you want to contribute or send me your feedback, go to github.com, Spring Project, Spring Foo, create issues. You can join me on Twitter. Really, this is the first time I show that in a big conference, so I'm really looking forward to feedbacks. Obviously, the DSL could be improved. There is various things to discuss. There is already various issues about the schema-first approach. I really would like to have something on that topic. So there is, Spring Foo is a place where we can experiment things around this kind of Kotlin / functional bin registration, but it can also apply to other topics. So feel free to come and to contribute. There is already 10 external contributors, including Thomas Girard, which is the guy where I discussed this principle at Montpellier a few months ago, and thanks to him. So yeah, feel free to come. In terms of roadmap, I plan to write a Spring Security DSL that will leverage Spring Security 5.1 Java DSL to be able to configure that. So I will work with the Spring Security team because I really believe that a Kotlin DSL for Spring Security that could be also reusable in regular Spring Boot annotation-based program will be super interesting. I plan to work on a Coroutines SQL support. So I guess you have seen all the announcements around R2DBC about Spring Data support for a more reactive and thin SQL layer. And I really think that with this kind of full design principle, it makes more sense to use things like reactive SQL with not a full-fledged Hibernate thing. So this is something I would like to work on to provide both reactive and coroutine SQL API available in this kind of application, because I intend to only work on the Webflux stack, since coroutine allow to provide a more imperative style API, And since we currently provide only the router API on Webflux, I really would like to focus on this new web stack that coroutines make easier to consume if you just want to do basic use cases, okay? I will also work on the Gradle Kotlin DSL support for start.spring.io, so just need some time to work on that. The light Kotlin reflection support is interesting. Kotlin is super well optimized. It's coming from mobile world, so on server side, we have almost no penalty to use it compared to Java, except on one topic, it's on Kotlin reflection. Kotlin-reflect artifact is fat, it's 2 megabytes just for reflection. It's bigger than the whole Kotlin standard library. It's amazing. And I have done some benchmarks and some flame graph, and it produced a lot of GC pressure, and it slowed down the startup a lot. So the plan is to collaborate with the Kotlin team. They have already provided a prototype of a light Kotlin reflection, which is a new library that provides just a less Kotlin reflection feature, but exactly the scope that we need. I plan also to discuss with the guy in charge of Jackson Kotlin module to leverage that as well. And the idea will be to be able to leverage this light Kotlin reflection thing. Notice that Spring Framework 5.1 allows to run Spring Framework without Kotlin Reflect. That was not possible with 5.0, and I have tuned a little bit the thing, and now it's possible. So if you don't need any Kotlin reflection, it's possible, and Spring Framework will gracefully adapt to that. The last thing is more, I would like to play a little bit with that. You have, with GraalVM, or we only use it only with GraalVM and with GVM performance. The performance are really linked to the number of class loaded. So we don't really care if Spring Jar carry more stuff about that, because the startup performance is, and the memory consume is more about the classes you effectively load. And here we don't load any annotation stuff, so we load less class. But I thought it would be interesting to be able to filter the class path, because it would allow to provide less classes in autocomplete. It will make ID or Eclipse consume less memory when you develop a Spring application. And in fact, we can't change the granularity of Spring artifacts because of Jigsaw, especially, and because we don't want to. So Spring Jar granularity will stay the same, will be the same, but Spring is very well architectured in terms of packages. With no cycle between packages, we take care really seriously about that. So the idea will be to provide a Gradle plugin which would allow to say, for example, I'm using the functional profile, so don't carry all this additional stuff. Or here I'm using just the Webflux client, don't provide the server stuff. This kind of profile where you can fine-tune what is actually integrated. I have not the time currently to work on that, so if you want to contribute, feel free to come. I have discussed with the Gradle guys, it's totally doable. It will be taken in account in the IDE. The classes won't be in the created jar. So this is something that is entirely doable, so if you want to help, feel free to come. The next steps are, there is a lot. The first one is to listen your feedback, and I will be careful about listening what you like and what you dislike. Obviously, this is the very, very first version, so it needs to mature. So mature Kofu and Jafu in Spring Foo, a lot of Foo, to make them production ready. Find the right balance API to avoid too centralized configuration. In Spring, we are coming in a world where every configuration is split into all the projects via annotation. I think there is some advantages to have a more centralized thing, but also it needs to be composable, and functional API are all about composability. So I think we could find the right way. For example, maybe the beans and the router configuration should be only externalized, and we should not support that directly into applications. There is bean scanning capabilities. There is various things that we could maybe do on the API side to avoid too centralized configuration. Also, it's designed for microservices, so if you have a huge configuration, maybe you need to split your application more, but I think it should scale for very big monolithic application as well, so there is some work to do that here. work toward built-in coroutine support in Spring Web Flux and Spring Data. We need cold stream support for that on coroutine side, so I hope Kotlin guys will provide that. Evaluate with boot team if boot can provide natively a way to leverage configuration in a functional way. That's something we need to discuss as a team. And improve testing support and continue to collaborate with GraalVM team to make Spring application runnable as native images. And it's not only about the Kotlin and the functional stuff. This also will impact positively the support of regular Spring Boot annotation-based application as well. To finish, Kofu is not better or worse than, there is a mistake, auto-configuration. It's different, so I don't want to start any bashing against auto-configuration. Auto-configuration is super nice. I just think that with an advanced language like Kotlin and with the culture of Kotlin developers, because I discuss with Kotlin developers that are not from the Spring world, there is maybe a different approach that would be a better fit for this kind of people and that fully leverage Kotlin features. And I think Kofu could be a way for Spring Boot to reach developers coming from other backgrounds, Kotlin, pure Kotlin developers, Go, Node, Ruby, and I think it could be complementary to our regular offering for Spring developers, which are perfectly fine with annotation, even in Kotlin, and there is nothing wrong with that. So thanks a lot for your attention, and if you have some questions, I'm available to answer them. Thanks.